For Module 5, Lesson 30, we are going to look at using number bonds, and in this case it's going to be fraction number bonds, to our best benefit to solve certain problems. So what we have here in number 1 is we recognize that we have a whole number and a fraction, and we're going to add another fraction. So in this case, this is going to be 1/4 and 1/4 equals 2/4, and the whole number stays the same, 3 and 2/4. You could simplify to 3 and 1/2. In a problem like this, we're going to take the 5 as the whole number, plus the 3 and 2/8 to get 5 and 5/8. In a problem like this, you have the whole number 6, and you have the 1/8 plus the 7/8, which equals 8/8, plus that original 6. So 1 plus 6 equals 7. I love these problems. What we have here is we have a certain amount, 4 and 7/8, plus something to get us to 5. Well, we know that in order to get this to 1, we'd have to make this 1/8. So 7/8 plus 1/8 would get us to 1. 1 plus 4 equals 5. In this problem, we have a total of 3. We're 2 whole already and 1/6. So what do we add to 1/6 to get one more whole? We add 5/6 to get there. The next section is what the lesson's all about. The idea here is, in this fraction, we are going to have enough when adding to create a whole number or a whole fraction, and we might have a little bit more. So in this case, since I have 2 and 3/4, I only need one more fourth to add to 3/4 to equal a whole. So this combined equals 3 now. 2 plus this 1 is 3, and then this additional 1/4 giving us 3 and 1/4. Similarly, in this problem, we already have 3 and 3/5, and we have 3/5 over here. So how many of these 3/5 do we need? We need 2/5 of the 3/5 to equal 1 whole. So 1 plus this original 3 is 4, and the remaining, fifths, well, 2 plus what gets us to 3? It would be 1/5. So it would be 4 and 1/5. A few more problems on this. So again, what you're going to do is you're going to decompose one of these fractions to make them more usable. In this problem, what do I need? I need 1/3. So now that I have that 1/3, I can recognize this would be 4, this would be 1, making 5, and 1/3 plus what gets us to 2/3? Another 1/3. This leftover 1/3 goes over here. Continuing on. In a problem like this, we have a whole number 7. We have 7/10 and 9/10, and it doesn't matter which one we decompose, but say I know I only need one more tenth to get 10/10. So I create 1/10, and that would leave 6/10. So 1/10 and 9/10 is going to equal 10/10 or 1. So we have 1 plus the whole number 7 to equal 8, and the leftover fraction would be 6/10. Continuing on, we have this 2 as our whole, 70/100 and 87/100. Again, it doesn't matter which one we add up. Personally, I like the idea of getting this to 100, so I would need 30/100 in order to make this one whole, okay? If I get this, I know this is going to equal 1, so 2 plus 1 is going to give me 3. If I take 30/100 from 87/100, that will leave me, well, what is 87 minus 30? That would be 57/100. So the answer would be 3 and 57/100. We're just decomposing one fraction to complete a fraction and identify a remainder, kind of like in long division. And our last problem, and I think this is an interesting one, what we have here is 2 different ways to look at this. So we have the problem, it's 7/9 plus 5/10. And Maria says, okay, 7/9 plus one more tenth will get us to a total of 8, because 9 plus 1 is 10/10. 1 whole plus 7 equals 8. And by taking 1/10 here, we would have a leftover 4/10. So we would have broken that 5/10 into 1/10 and 4/10. The 1/10 added to the 9/10, and the 4/10 is kind of like our remainder. And that's how you got your whole number and 4/10 equaling 8 4/10. Additionally, Paul thought he had the 7 whole and he added the numerator, creating a mixed improper fraction. And then what he did was kind of exchange out or cash out 1 whole. So he got 14/10, knew that that's too many, so we cashed out 10/10 cashed out 14/10 into 10/10 and 4/10. 7 plus 1, and then you have this leftover 4/10 equals 8 4/10. Both are correct. Maria broke her 5/10 down into a 1/10 and a 4/10, whereas Paul ended up going into improper form and then cashing out to have it kind of reflect in a way a mixed number that we can accept. Both are technically correct.